Solving problems with percents that are greater than 100% are often difficult, but you will see illustrations here to provide understanding of the given information and the solutions. Percents greater than 100% are represented by more than one unit square, as shown in the following problem. If a school's population for the new year is 135% of the school's population for the old year, that is the preceding year, and the new population is 756, how many students did the school have in the old year? To represent 135%, we need two hundredths squares, and we shade the first square for 100% and the second square for 35%. We label the shaded region to represent 756 students. To find the value of each small square, we divide 756 students by the 135 small squares. 756 divided by 135, and this equals 5.6 students per square. And we label one small square 5.6 students. The school population for the old year is the value of the unit square. And this is 100 times 5 6/10, and that's equal to 560 students. The 135% used in this example can be written as a mixed decimal 1 3500ths. And using the percent formula, we can check the results of this problem. 1 3500ths times the whole, which is the unknown, equals 756 students. And the whole equals 560 students. So the whole, the population for the old school year, is 560 students. And notice that the part is greater than the whole because the percent is greater than 100%. If the first year profit for a business was $32,900 and it increased 76% in the second year, what was the profit for the second year? These squares represent 176%. The first square represents the first year profit, and we label this $32,900. And the second square represents the increase in profit for the second year, which we label 76% increase. We obtain the value for each small square, 1%, by computing 32,900 divided by 100 equals $329. And we label one square $329. The value of the 76% increase is 76 times 329, and that equals $25,004. So the profit for the second year was $32,900 plus $25,004, and that equals $57,904. The The second-year profit of $57,904 can also be found by multiplying the value of one small square, $329, by 176, the total number of small squares. Let's look at one more example of a percent increase. In the first year, the price of each share of a new stock rose 125% to a year-end value of $33.75 per share. What was the original price of each share of stock? The unit square represents the original price of the stock, and the 125% increase is represented by these two green squares, and we label the $33.75 year-end value of the stock. Notice that if we were given the original price of the stock, we could find the value of one small square by dividing by 100. Or, if we were given the dollar amount of the 125% increase, we could divide by 125 for the 125 small squares to determine the value of one small square. But we are given the year-end value of $33.75, and this includes the original price of the stock and the 125% increase. So we find the value of one small square by dividing $33.75 divided by 225 equals 1/1500ths of a dollar, or 15 cents. And we label one small square as 1/1500ths of a dollar. The original price of the stock is now easy to find. We multiply 100 times 1/1500ths of a dollar, and this equals $15 per share. Notice how the diagrams for the 100 squares illustrate the given information: the original cost of the stock and the 125% increase. These squares also show how to write in the amounts for the percent formula. For the percent, we write the mixed decimal 2 and 25 because the year-end value includes all three squares, and this is 225%, times the whole, and this equals $33.75. That we can divide by 2 and 25 to obtain the original $15 price of stock. The next problem involves tenths of a percent. If a home loan requires a down payment of $98,900, and this is 21 5/10% of the loan, what is the total amount of the loan? This square is shaded to illustrate 21 5/10%. And 5/10 of 1% are shown by dividing one small square into 10 equal parts and shading 1, 2, 3, 4, 5 of those parts. The 21 5/10 down payment is $98,900. The value of each small square is $98,900 divided by 21 5/10, and that equals $4,600. And one small square represents $4,600. The total amount of the loan is 100 times 4,600, and that equals $460,000. or using the percent formula, with the decimal 215 thousandths used for 21 5/10%, $98,900 can be divided by 215 thousandths to obtain the $460,000 amount of the loan. This is the last of 14 videos on decimals and percents. The visual demonstrations in these videos will be helpful to students in understanding and learning these important topics.